Hi, welcome to Hacker Heap. In this video we will look into solving the coin change to problem. Let's go through the description. You are given n coins of different denominations and total amount of money. Write a function to compute a number of combinations that make up that amount. You may assume that you have infinite number of such kind of coins. So the example given is the amount should be 5 and the coins given are 1, 2 and 5. It says like you can use any number of coins of denomination 1 and any number of coins of denomination 2 and any number of coins of denomination 3. So for this the different combinations that we had is to get amount 5 is adding all ones, 1, 2 and 3 ones, 2 2s and 1 1 and 1 5 from the given coins. So let's take a different example. Let's take an example 1, 2 and 3 and the amount be 4. Amount be 4. So what are the different possibilities? Let's think through it. So the possibilities are you can have 1 plus 1 plus 1 plus 1 and 1 plus 1 plus 2 and 1 plus 3. And the other one is 2 plus 2. So there are 4 different ways to get amount 4 using the given denominations, given that you can use a single denomination any number of times. So this is actually a dynamic programming problem. So let's see the brute force application. Given the amounts 1, 2 and 3, generally what we do is we generate all different combinations with the given numbers until the amount is equal to 1. So let's draw a tree related to that. So we will take 1 and we will add 1, add 1, add 1 until it reaches 4. Basically in every step we were checking if it is less than or equal to 4, less than or equal to 4, less than or equal to 4. So that's what we were checking in every step. So now we reached 4. What we need to do is we need to backtrack by removing each of this. So we will remove this, we will remove this and go back here and check if there are any denominations of the difference of 4 minus 2. So we will add that here. So we will add that here 2. We will add that here. So we had one combination here, and since it is equal to 4, we will have a counter which we increment every time 1 plus 1. Now we will go back here and we will backtrack to this one, and what we will do is we will check if there are any denominations of the difference of 4 minus 1. So there is 1, so we will add that here. So we got 4 and we had this counter as 1 plus 1. So totally we got like 3 different variations. Now we will start with 2 and we will check 1 and 1 and it results to 4. So the problem here is we are creating duplicates of these combinations. So we don't want to do this. That is the reason, and it will take a lot of time. The time complexity would be like n square star m, which is the total amount. So we don't want to do this. That is the reason we will go with dynamic programming approach for this problem. So how do we do that? So let's take a basic dynamic programming approach. So the general syntax for any dynamic programming approach will be like given an array and find that maximum or something like that. So the basic is like you define an array dp of length which is greater than the amount plus 1, and you perform your operations on how to do this. Perform operations and just return dp of amount, which will hold the cumulative sum depending on like what operation you perform in between. So this is the basic format. Okay, you will define an array of the given amount plus 1 and return the DP of the last index. Basically that will hold the result. So in between what you do is so important. So for this particular problem, what we need to do is, so we need to find the number of combinations that will result in this amount, right? So for that, let's take this example again, 1, 2 and 3, and amount is equal to 4. So what we do is we initialize an array with amount plus 1 size. So 1, 2, 3, 4, 5. And we will initialize DP amount, the first index to 1. Now we will loop through this array, and what we do is we will update the indices. So for I is equal to 0 to the length of the array, and we will assign j is equal to the array of 1, a of I. So now, and j less than the amount, which in this case is true, and j plus plus. So for this case, what we need to do is we need to update these indices. So we will update this dp of j plus, we need to add to this 1, so dp of j minus a of I, which in this case is 1. Now again the j increments, and it will be 1, 1 and 1. This is iteration 1. Coming to iteration 2, it will be j is equal to 2 and j less than the amount. So we will start from here and we will start incrementing it 2, 2, and this becomes 3 because dp of 4 is at 1, and we need to dp of 4 minus a of I, which is 2. So dp of 2, which is 3. So again we do the same process for the last, and this ends up becoming 4, and we return this value. That's all we need to do. Let's go ahead and code it out. So as I mentioned, we will go ahead and define this. Amount plus 1, and now the first index to be 1. Now for int I is equal to 0, I less than coins dot length, I plus plus, j is equal to coins of I, so j less than the total amount, less than or equal to the total amount, and j plus plus. All we need to do is update that particular index of j, adding the index of dp of j minus coins of I. That's all we need to do, and just return the last index. So return dp of amount. That is it. So let's go ahead and run it. So I had taken some other example, just submit it. So yeah, it's good. Hope it's clear, and if you like the video, please like and subscribe to the channel Hacker. Thank you.